we have x, y, which are both positive, and the square root of xy times x minus y, and the geometric mean of x and y times their difference is equal to their sum. Find the minimum value of the sum of x plus y. When we look at this expression, we see we're dealing with radicals, but it's usually easier if we don't deal with radicals. So let's start by making some substitutions. Let a be equal to square root of x and b be equal to square root of y. So the given condition becomes ab times a squared minus b squared is equal to a squared plus b squared. Now let's do some more substitution. We're going to let capital S be equal to the sum of a squared and b squared, and we're going to let d be equal to their difference. So we get ABD is equal to S. And we're going to call this the first equation. Now let's focus on S, because S is what we're trying to find the minimal value of. It's what we're trying to minimize. So by AMGM, we know that S, which is equal to a squared plus b squared, must be greater or equal to 2 times AB. This means that if we resubstitute S with ABD, it's going to be greater or equal to 2AB. Now we can divide AB on both sides, so D must be greater or equal to 2. And usually when you have a x plus y and then an x minus y, in this case S is the sum and D is the difference of two terms, you can think of the perfect square. Because when you square both of these expressions, in the end you get something very similar. So let's try to square S. If we have S squared, that's equal to a squared plus b squared squared, which would be equal to a squared minus b squared squared, but in the end you would add on a 4a squared b squared. So pause a moment to see if you can digest that. Awesome. Now let's move on. We replace the a squared minus b squared with the difference, d squared plus 4a squared b squared. Now, how can we rewrite this AB in terms of S and D? Well, from equation 1 that we found earlier, we know that AB is equal to S over D. So this equation can be further rewritten as D squared plus 4 times S squared over D squared. And now we're left with S squared is equal to this expression. Now let's go ahead and subtract 4s squared over d squared on both sides. We can factor out the s squared. When we simplify, we are left with s squared is equal to d to the 4th over d squared minus 4. So let's mark that for now. Remember, in the end, our final goal would be to minimize S. We have to keep that goal in mind, or else we'll forget what our original purpose is. So if we have S being expressed over here, how can we try to bound it? Well, we can put some bounds on D. We already know that D is greater or equal to 2. So let T, we're going to make a new substitution, be equal to D squared, because we can see D squared appearing here pretty often. And what's the bound of T? Well, T would be greater than 4. And why can it not equal 4? Well, look, we have D squared minus 4 in the denominator. So D squared cannot equal 4. So D squared must be strictly more than 4. So then this S squared, let's move it up here, would be expressed as t squared over t minus 4. Now we have a t in the numerator and some t's in the denominator. So how can we apply the AMGM inequality? Well, this fraction can be split up into t plus 4 plus 16 over t minus 4. This is equal to 8 plus t minus 4 plus 16 over t minus 4. We wanted to make it such that we have a t minus 4 in the numerator and a t minus 4 in the denominator. Now when we apply the AMGM inequality, we have 8 plus 2 times the square root of 16. So this is equal to 8 plus 8, which is 16. S squared is greater or equal to 16. Now we want to minimize s. So we have s is greater or equal to 4. This means that s, which is x plus y, is greater or equal to 4. Now before we commit to this answer, we have to double check the equality condition. Equality holds when t minus 4 and 16 over t minus 4 are equal, because this is what we apply the AMGM inequality onto. We see that this gives us t squared minus 8t is equal to 0. So this means that because t cannot equal 0, t, remember we said earlier that it has to be greater than 4, t is equal to 8. So that would mean d, which is the square root of t, is equal to 2 times the square root of 2. And what was d in the first place? Well, we know that d was a squared minus b squared. So a squared minus b squared was equal to 2 times the square root of 2. If you simplify, you will find that this is true when x is equal to square root of 2 plus 1 squared, and when y is equal to square root of 2 minus 1 squared. And because both of these numbers are positive, it meets the original condition for x and y, which means that it is possible for equality to hold true. So it is true, it is valid for us to write down this final conclusion. Our minimum value of x plus y is 4. Now here's a recap of what we did in this video. What we did was we applied substitution a lot. That's a technique. Another technique that we used was bounding. Every time you introduce a new variable when you're making new substitutions, you should always remember to define the bounds of this new variable. And finally here, we manipulated the expression in order to apply the AMGM inequality successfully. And finally, what we did was we double-checked the equality condition. That way, we can make sure our answer is correct, because sometimes the equality condition cannot hold, and we can't have greater or equal to sign. We have to write a strictly greater than sign. Thank you for watching this video, and I'll see you in the next one.